A very good afternoon. Myself Sanjib Rajbongshi. I am going to present on powder metallurgy. So what is powder metallurgy? Powder metallurgy, it is a process in which metallic powders are heated below their melting point to achieve the bonding. The powder metallurgy process involves three major steps, which are blending and mixing, compaction, sintering. So blending, what is blending? Blending, it is the mixture of the powder of the same chemical composition but with different sizes. Mixing, it is the combination of powders with different chemical or different chemistries. So blending and mixing, they are accomplished by different types of mechanical means. So such as in rotating double cone, screw mixer, blade mixer. Except for powder, some other ingredients are also used in powder metallurgy process, like lubricants, binders, deflocculants. So in compaction, there are two types we are using actually, with pressure and pressureless. In pressure, we have cold isostatic process, hot isostatic pressing, high energy red techniques, vibratory compaction, continuous compaction, forging or extrusion. In pressureless, we have slip casting, gravity compaction, continuous pressureless techniques. So in compaction pressure, cold isostatic pressing, it is actually in the process in which powder is placed in a flexible rubber melt using the hydrostatic pressure up to 400 megapascal in the chamber with water. So typical application is automatic cylinder liner. So this is a diagram for the process called isostatic process pressing. Hot isostating process, in hot isostating, the powder container is usually made up of high melting point sheet metal, and it is occurred in the inert gas and atmosphere at a pressure of 100 megapascal and temperature of 1100 degrees centigrade. The advantage it is like 100% density, good metallurgical bonding, and good mechanical properties. Limitation, it is high dimensional tolerance, greater cost and time is required. This is the diagram for the hot isostating process. Next, high energy red techniques. Here actually, in high energy red technique, explosive or spark discharge methods are applied in a closed die in short time and in high pressure. For vibratory compaction, here the process is occurred with simultaneous application of pressure and vibration at very low pressure, and the disadvantages here actually, it is complicated design is required here. Continuous compaction, it is generally applied to some simple shapes like rod, sheet, tube, plate, etc. The figure showing flowing loose powder between a set of vertically oriented rolls at much lower speed. Here, two rollers we have shown here. Loose powder has been supplied using a hopper and it is compacted at very slow speed. So then forging or extrusion. So forging is the process applied, that first one is powder, the canning of powder. Second one is heating or evacuation in a sealed container, followed by forging or evacuation. After that, mechanical or chemical revision of container material. This is the diagram of the extrusion forging process. So this is the typical compaction pressure for various applications. Then pressureless casting, then pressureless compaction. In powder material we have slip casting. Then slip casting, what is we have done? The preparation of slip powder suspended in liquid and additives. Then next one is keeping the slip in mold up of fluid absorbing material. Then formation of slip casting, then removal of slip followed by drying operation. Continuous pressureless technique. Here actually powder is applied in the form of slurry. It is used to produce sheets for electrodes of nickel cadmium batteries. Then sintering, what is it actually sintering? Sintering, here compressed metal powder, it is heated in a controlled atmosphere. It is heated below its melting point but high enough to attain the bonding strength of the particles. The purpose is to consolidation and drying. Principal variables are temperature, time and furnace atmosphere. The sintering process is generally concerned with diffusion, densification, recrystallization and grain growth. So the process here, the in this diagram, it is showing that the sintering process, the driving force, which is not a fusion of material but formation and growth of bonds between the particles, it is shown in this diagram. So this is the powder metallurgy products. The first one is raw powder, then formed product. After this one, it is sintered product. So this is for some typical materials, the sintering temperature with sintering time. So then the finishing and secondary operation, which is sizing, cold pressing. It is sizing. It is a cold pressing process to improve the dimensional accuracy. Then coining or pressing, it is a cold working process. Impregnation it is the process, it is heated with like self lubricated bearings. Infiltration, it is placement of slug of lower melting metal against the sintered part. Then last one is heat treatment, plating and painting. So finally, at a glance, the powder metallurgy process is metal powders and additives. It is after this blending and mixing process, then it is compacted, then sintering, then the last two processes, secondary manufacturing and secondary finishing, it is done. Then after the final powder metallurgy product is obtained. And these are some typical finished powder metallurgy product use the powder metallurgy. So some bearings, some pistons, some electrical appliances, it is being used using the powder metallurgy process. It is formed by powder metallurgy process. So thank you.